In previous class, we discussed about MapReduce. That we discussed that what are the functions that users provide, what are the functions that Hadoop provides, what are the inputs that we have to mention, output that we have to mention, how we have to do map coding, how we have to do reduce coding. All these things we discuss about, and then we see what map reduce cannot do. So all these things we discussed in previous classes about batch processing means uh, a sequence of data is already been stored in some hard drive and you have to do processing sequentially, that is batch processing. So we discussed about word count of large books are there, and we seen a small example for that. So how frequency of word could be calculated. Similarly, if you have we have discussed about the counting of number of students in a class, that there are three volunteers are being selected randomly and they have to count students in their own row, and then the result of three rows would be added and we'll get the strength of the class present in that day. So these are the type of word count basic example. So these are the example which will be taken forward and done some complex map reduce coding. So there are various kinds of examples like this. If you are interested in that, you can go and see over them, and that is part of some basic big data analytics. Then today we are going to discuss about real-time stream processing framework, that is Storm. What is Storm? Storm is a kind of framework that processes real time streams and in the distributed fashion. How they process? The same way like Hadoop do, it creates a collaboration of multiple computers together, and these are joined together and they used to process batch data, means in the batch processing format in Hadoop. In Storm, it creates a distributed environment for real-time streams coming, and these multiple computer will process these streams in distributed fashion. Now, it's a kind of reliable processing for unbounded stream. What are the examples of unbounded streams? Suppose Twitter have continuous tweets coming on, and you are the Twitter engineering, and you need to mention what are these tweets, what are their trends, what are the different kind of trending topics going on, 10 top trending topics. These are the real time display or results you have to provide. Means just in 30 minutes this topic had become more trending, so you have to mention that trending topic in top. So this is the kind of real-time unbounded stream processing. Means Twitter works 24 plus 7. So you cannot stop that processing, and you need to keep on working for in real time. Any questions? So the Hadoop is for batch processing and Storm is for real-time processing. Real-time analytics basically deals with the results that are required in real time, means you need it immediately and you need its result immediately, and immediate processing is required, immediate understanding and business logic should need to be encoded. So these are the example of real time analytics. So we are going to discuss about its framework, that is Storm, for doing the real time analytics process. Then online machine learning is an example. What is online machine learning? It is like machine learning going every time, means real time, and you do not stop that machine learning and training and recommendations, and it keeps on going online, means it will never stop, and you'll have continuous training and continuous recommendations. That is online machine learning. and continuous computation is required because we are processing in real time. We want real time results. Thus, what is the basic necessity of that? Basic necessity is to do continuous computation, and that should not be stopped. Then you have distributed remote procedure calls. What is that? In that distributed remote procedure call, you have various procedure calls which are uh, allocated at different machines for doing this kind of processing. What does this mean? So you write code for doing processing, and you transfers those codes to the location where the tweets are coming in, and you start processing. And that's remote procedure calling, means you basically calls some data somewhere in the particular stream or particular server, and you process it there itself. So that's the distributed real time process calling, remote procedure calling. So these are the impacts of and functioning and functionalities of a Storm Life real-time framework. Then what are the examples that we are discussing? We are going to discuss. Suppose there are millions of tweets coming in. What are the tweets? They can be represented as tuple of information, that post is coming, some images are there, some videos are attached to that. So these are different kind of tuples. So millions of tuples, and that user id is being mentioned over in that tuple. Then name of that user id is being mentioned in that tuple. Timestamp is being mentioned in that tuple. So the millions of tuple keep on coming from Twitter, and you need to process it in different nodes at every second. What does that mean? You need to make a real-time analytics system in scalable and fault tolerant, and guarantee that your data will be processed. So that kind of work is being provided by Storm framework, which is one of the easy way to set up and operate. Nowadays, what happens? Spark came up after Hadoop. Means Hadoop has been having MapReduce. So Hadoop had modified and improved itself, and it started uh, a new project. Apache Hadoop had started new project, new, that is named as Spark. So Spark is also work as real-time stream processing framework. It Spark works for both batch processing as well as for real-time analytics. So that's the new innovative Apache project that is named as Spark. We'll discuss this Spark in later on classes. And Spark is basically very good for learning uh, parallel and distributed computing framework because it is now popular and successful one. Then fundamentals of Storm. Storm has four fundamental things. Two are mentioned here: topology and streams. Then we'll discuss spout and bolts. First of all, in Storm, there's a definition of topology. What does topology means? Topology means whatever you had discussed about map reduce. First, you have to do mapping, and the intermediate result would be generated from map, and then you have to reread that intermediate result and do the reduction. So that reduction will produce final output, that is map reduce. And that map reduce used to work for batch processing. Now you want a real time batch processing, means real time map reduce. So what proposed for that topologies. So MapReduce actually finishes some job whenever the data reading sequential would be finished. But when a real-time streams are coming and they never stops, means users are keep on posting whatever be the time, keep on tweeting whatever be the time, 24 cross 7, then you need to run a system which runs forever. So topology basically runs forever until you intentionally stop that process. And till that time, this topology keeps on working. So basically, what is topology? Topology is a graph of spout and bolts. What is topology? Topology is a graph of spout and bolts. This is the example. So spout have connected to and send some streams to bolt a do the processing and send new streams to bolt b. Similarly, spout is sending some streams to bolt c. So these three, bolt a, bolt b, bolt c, are the three different kind of processing unit. It's similar to like you have a tap of water and you need to store some tap of water and flow of water from bolt A, tank A, then it will go to tank B, and that stream would go to tank C. What does it mean? It means that in tank A you do some color mixing on that water, then in tank B you do another mixing of that water, or you have some industrial pipeline. So chemicals you'll mix in tank A, chemicals you mix in tank B, and then you'll have the collection of the result of the whole processing of that water. So water treatment plant works like this. It keeps on coming, that water flow keeps on coming in the different kinds of tank, and different kind of tanks would do the water treatment. And at the end, it will have some clean water separated from dirt, and you'll have better water. So this is the way actually this storm works in the real time. We discussed about topologies. So topology is basically graph of spout and bolt that are connected to process some group of streams. That is topology. Now we have to discuss and think about what are the streams, because we are technology, so we have to define it properly. Streams are unbounded sequence of tuples that are needed to be processed and create in a parallel distributed fashion. So streams are like what we discussed as tuple. Tuple means in a tweet you will have user ID, username, timestamp when the tweet has come, what is the text in that tweet, is there any image attached to it, is there any video attached to it, who are the tagged member or tagged event. So you have to mention that tuple, and that tuple would have what would be processed in such storm. These tuples are being said as streams, and these tuple have to be forwarded in such a fashion that it will go to distributed computer, means different computers in a parallel way for processing, means because every computer has its own computational power, and multiple computers will work faster than a single large server. So multiple computer would have multiple streams, different streams. They start processing these different streams, and they'll send them a merged a result. Each of them will send some kind of result to single larger server, and that server will merge that whole aggregated results, intermediate results, and then generate the final result. Then streams are defined with some schema that name the field in the stream tuple. What does it mean? Streams are defined in schema. Schema is basically data structure, advanced form of data structure. Data structure is What we have seen is int and float, binary. There are various kinds of data structure we have seen. But what happens when we have some advanced data structure? We'll start saying it is schema. Schema means how these are different data structure are being combined together to form some schema. Means what should be the input, what should be the output. Four integer could be there, four text could be there. Then MIME means some video and images type of data could be there. So these are the various kind of schema that are being mentioned in the streams, and various fields are being mentioned. Twitter account ID, Twitter name, text in the tweet, blog means that video or image. Then you'll have some links attached to that. So these are the kind of tuple you can see, and fields you can see in the streams of tuples. Then schema could be like integer, long, short, byte, strings, double, float, booleans, byte, array. So these are combined together. Then they'll be said as schema. Schema basically represent some data structure of input, some data structure of output. It's advanced form of naming data structure. Then every stream is given an ID when declared. It's similar to the relational database. In relational database, you will have static data, but in this real-time streaming, you have streams, and that streams would have tuples, and each tuple would be having ID. Similar to that relational table have some transactions. Every transaction would have some ID. Similarly, every tuple of stream would have ID. So this is how you will start declaring some ID. Then next, spout. What is a spout? Spout is basically source of streams in the topology. What does it mean? Means there has to be some entry path where that topology could start doing processing. It's like you are getting packets from network. You'll store somewhere in the hard disk for temporary, or you'll just have in the in the that RAM memory or some memory which could work faster like cache. So what happens? You'll have some memory over there, but there is a process going on which process that packet and forward it to the topology. So what should be that process? That process is spout. A spout is the source of that stream in the topology. What it does, it basically reads that packet, it extracts that tuple, it emits that stream to the and emit that tuple to the bolt. So what happens generally, Spout will read these tuples from external source. What is that external source? Source that is packet coming from outside internet, and that Spout will read those packets and find out these tuples, parse those tuples, and then emits them to the topology. What does that mean? It will start doing processing. So that's the entry point of storm. Spout. There are two types of spouts possible: reliable spouts and unreliable spouts. When you have some guarantee to be there that this tuple or this stream has been processed perfectly, then you do the reliable spout. So what does it mean? If some tuple is being failed to process, then reliable spout will again replay and reprocess that and resend and re-emit that tuple because that tuple is being failed earlier. But what had happened in unreliable spout, when there's lots of data coming, and that data is not much of use. For example, there are various sensors in the traffic. So what happens? There's lots of data coming out from these sensors on road. So these roads sensors keep on sending the data, keep on sending the data. What happens? They have totally useless some of the time. So you just need to process these tuples and generate some information out of it. So in such cases, you use unreliable spout. Means if some spout or some data of sensors are missed in the road sensors. So in the smart city, so it is not necessarily that you rethink over that sensor, what should be that sensor data or what should be happening at that particular instant of time, because you don't have capacity to invest that much resources of computation or processor or RAM. So what you do, you just apply unreliable spout. It will check whether that computational power is capable or not. That spout will, that information will come. If a spout will transfer it to the bolt, and bolt will start processing it. If it processed it, it's fine. Otherwise, if there's less amount of resource, computational power, CPU, RAMs, then it will forget about that tuple, and it will not care of that spout will not care. So that is unreliable spout. Means it emits and it forgets. So both the things are important: reliable spout and unreliable spout. But how reliable spout is important? Because humanly tendencies are involved. Means in the tweets, you have some human involved. Every tweet is important. In these sensors in the road traffic or something, you have too much data which is coming in and you don't care about that data. So you apply unreliable spout and just process it once, whatever being processed, and you will find out some result as information, and you will store only that information. Even that sensor streams which are coming, it will be ignored or deleted after all the thing information is being generated, because it's useless to store such large amount of data and wasting disks space. Thereafter, bold. This is the most important part where you put the logical code, business logic, or some mathematical formula, and all these processing are being done on bold. It's a simple programming that you do, and all these both things, that Hadoop, Spark, HDFS, Storm, all these things are written in Java. Java is one of the most efficient coding language that you can find out. So these larger framework works on Java technology. This is what it makes Java better than Python. The larger projects are being developed on Java. Google works basically, backend works mostly on Java. Microsoft mostly backend works with C++, C sharp. So these are the basic technologies that you should must learn as a computer science engineer or information technology engineer, data science engineer. Then all the processing will come to the topic. All the processing should be done in the bolt, because spout transfers the emits the data or tuple or stream to the bolt, and bolt can do functions like filtering, aggregation, joining, talking to database, or many more other functions it can do. Then bolt can do what? Stream transformation into new streams. Means the way spout transfer the emits some stream, the bolt can also transform that stream by processing and then again generating some stream, and it will again send it to some other bolt and the distributed and reliable fashion. Where's the example? This is the example. Bolt A is retransmitting, re-emitting some streams to Bolt B. Then Bolt B will again do some processing. So Bolt A did some processing, then emitted that intermediate result to Bolt B, and now Bolt B will start processing. So it's similar to that map reduce kind of framework that has intermediate result after one map or two map or three map, then it will be done reducing, then reduction will again transfer some information to the another map, and then to the reduction second phase, then again data will be stored and third map function will read it, and again the reduction would start. So this is the similarly things in the spout bolt and topology, where you'll have distributed processing. Now what happens, complex stream are being transformed into multiple steps and multiple bolts are required. So what happens, there is some of the data which is coming as the first emitted stream, they are complex in nature. So the complex kind of transformation are needed in the multiple steps, and multiple bolts are required to be uh, inserted. Then for example, you have transformation of some streams of tweets into trending topics. So there are various kinds of trending topics, means sports trending topics, politics trending topics, or some disaster trending topics. There could be multiple trending topics. So you have to transform these tweets which are coming into multiple segments, means multiple genres, like I told, sports, politics, or some disaster. So these are the various genres. In this, you have to group these similar tweets in some similar bolt. In a bolt, you process and group them in a particular similar uh, genre and transform it to process in that particular genre, and particular genre bolt will do the processing, means there will be a main bolt which will separate out political tweets. It will send political tweet to political bolt, then that bolt A would again send it separate the bolt sports bolt sports streams. Then some disaster had happened, so that bolt A will merge all these things, combines the disaster tweets and send it to disaster bolt, and these three bolts would do the independent processing for politics, for sports, and for disaster. So this is how you will get the trending topic and different classification. So I hope that this map reduced batch processing and real-time stream processing is being clear. So in the next class, we'll start discussing about Google, how Google manages its architecture. We'll discuss about Google file system. We'll discuss about Google content management. In next class, we'll discuss about architecture of Hadoop in Google Cloud Platform, how web applications work in Google App Engine. So Google App Engine architecture we'll see. Google Web Toolkit we'll see. Thereafter we'll see Eucalyptus Cloud. So wait for the next class for Google File System and Google Cloud. So I hope the storm has been clear to all of you. Map reduce has been clear to all of you. Any doubt or any query or any example that you want to discuss, or something you have seen in such processing, or something you had worked in such processing. Okay, so we'll meet in next class. Bye for now. Thanks.